Hi. So in this video, we're going to look at an example of the discrete distribution, something that we haven't really covered yet, and something that's a little more infinite in scope, something that could take forever. Now the thing is with this one, it might look like the geometric distribution, but it's not. So just note that, but it's similar. So we'll see. We'll see in a second where. So let's look at the problem. So the problem is saying, let's say our friend decides to tell you that they're luckier than you. So one of your friends is basically like, "Ha, I have more luck than you do." They pick up a die and they say, "I bet I can get a 6 before you can." So notice how this is sounding like the geometric distribution. Who's the first person to get a 6? The difference here is that we're going to have to be switching back and forth between people. So each individual person is not going to have a geometric distribution. It's just going to be similar. Now, obviously, you've been doing this for a while. So before you actually agree to this, you're going to double check that your odds are pretty good. Like, you want to make sure you have a good chance of winning, not that you're going to lose, right? You don't want to have them win and then be like, damn. So what's the probability that your friend is going to win? So let's kind of look into this and dive into this a little more strongly. So we're basically asking when your friend is going to win and when are you going to win. So let's first calculate your friend. So when is your friend going to win? Your friend is going to win, friend wins, if first, third, fifth, seventh, basically, or odd number or odd roll is a 6. And you win if it's an even number. If second, fourth, sixth, etc., or even roll is a 6. Okay, so let's first figure out your friend's chances. So this part itself is like the chance of the ith roll being, so let x let x be getting a 6 in xth roll for first time, right? And so in this case, we already know this. This is geometric. So this geometric, which means that we already know this from previous things. So p of x is equal to k is given by 1 minus p to the k minus 1 times p. So if we use q, if you want to use q instead, this is q minus 1 times p. Okay, here, if you note, our q is equal to 5/6 and our p is equal to 1/6 because we're trying to roll a 6, right? Yeah, get a 6. Okay, cool. So what are the chances of your friend winning? So the chance of your friend winning is basically the probability that x divided by 2 is not an integer, right? What is this saying? This is basically saying not an even number. And this is where the strength of, like, notice how random variables are basically making it so I don't have to define a new event. I just say, just make sure this is odd. That's it. And that's it. It's nice and easy. So what does this give me? Well, this is just a sum that x is equal to 1, or x is equal to 3, or x is equal to 5, or ... So I can rewrite this. So basically, this is just, well, here, we'll go slowly. So this is just p for the first one, plus p times q squared for the second one, plus p times q to the 4 for the third one, plus p times q to the 6th, etc. So we kind of see a pattern here, right? Here I can pull the p in front, so I have 1 plus q squared plus q4 plus q6 plus etc. And this, you might want to recognize that this is the geometric series with q squared. So the geometric series is basically saying from I equals 0 to n, q to the I. This, no, sorry. Yeah, q to the I is equal to 1 over 1 minus q. So where does this fit into our thing? This is coming into it by doing squared, right? So this only works if q is less than 1/2. Q is sufficiently small. So we'll say, is it 1/2 or? So not 1/2, it's just less than 1. So whenever it's less than 1, which is generally what we have with probabilities, right? So for our thing, we have q squared to the I. So here we would have 1 minus q squared. So if you want to look this up, this is called the geometric series. It's a good series to kind of know for this part. So what do we get? We get p times 1 over 1 minus q squared. So at this point, we can just plug in numbers. So p is equal to 1/6. And then we get times 1 over 1 minus 5/6 squared. Let's calculate this. This we get 1 over 6 times 1 minus 25 over 36, which is 6 times, what's 36? I'll do this on the side. 36 over 36 minus 25 over 36 is, I guess, 11 over 36. So we get 11 over 36. The 6's here will cancel. This will 6. So I can bring the 6 above. So I get 6 over 11. So this is roughly a 54.55% chance. So your friend has a 54.5% chance of winning. So what I would say is it's probably not worth taking this bet, right? Like if they have a greater chance than you of winning, that means you're going to have, what, 45.44 roughly percent chance of winning, which is just not, it's less than them, right? So like it's not good. They have a better chance. So of course they're going to be luckier. Like they're destined to win. So yeah, so notice how we use this idea of discrete and geometric to kind of come together to kind of solve a problem. So problems are going to be a little more difficult from here on out because we're just looking at more arbitrary distributions rather than exact distributions. So yeah, so we'll end this video here. And in the next video, we'll talk about discrete moments. So I will see you then.